All right. So, last time we talked about triangles. Now we're moving to a circle. Specifically, the unit circle, which is a circle that has a radius of 1. So, from the middle to the edge of, or the perimeter of the circle, that length is 1. Whether it's that particular radius, or if it's there, or straight down, all the lengths of these radii are 1. So the unit circle has specific coordinates on the outside of this perimeter. We are interested in the coordinates at 30 degrees. Let's say this is 45 and 60. So we want to know the coordinates at these three angle measures. Now, to get to this point right here, we had to, if we start at the origin, we're plotting a point that's here. We had to go to the right, then we had to go up. But when we go to the right and then go up, we get a triangle. So let's pull that triangle out. So we have this triangle. I'm going to erase this part. But we have this triangle, and we know this is a right angle, and we know this side, or this angle, is 30 degrees. Because I told you they're 30, 45, 60. So if this is 30 degrees, and this is 90 degrees, right here, and a triangle has 180, that means this one has to be 60. 180 minus 90 minus 30. And we also know that this side length is equal to 1. So using what we have here, we can find the measure of these two side lengths, which this would be what I went to the right. So this is my x coordinate. This would be my y coordinate. So let's start with the y coordinate. This is the opposite side. This is the hypotenuse. So we're going back to solving triangles, which was in the last video. So we have opposite and hypotenuse. We're going to use sine. Sine of the angle, which is 30 degrees, equals opposite over hypotenuse. Sine of 30 equals opposite over 1. And again, we're just solving an equation. We want to get the opposite, or the O, by itself. So it's not a 0. So we have to multiply both sides by 1. Or O opposite over 1 is just O. And sine of 30, when you put in the calculator, is equal to 0.5, which we know is 1/2. So now our triangle looks like this. This is 1/2, this is 1, this is 30, this is 60. Once you have two sides of a right triangle, we can use the Pythagorean theorem to figure out the third side. So we have a squared plus b squared equals c squared. A is 1/2. We don't know what b is, so we're going to leave it. And c squared is just 1. If we solve this out, we have 1/2 squared, which equals 1/2 times 1/2, which equals 1/4, plus b squared equals 1. Subtract 1/4, and we get b squared equals 3/4. And then the inverse operation of a square is square root. So b is equal to the square root of 3/4, which equals the square root of 3 over the square root of 4, which is square root of 3 over 2. And I'm running out of space. So I'm going to erase this over here. But we know that this side, B, is now square root of 3 over 2. So our x was square root of 3 over 2, and our y was 1/2. Okay? Alright, so we found our coordinates at 30 degrees. Well, the 30-degree triangle is just the 60-degree triangle, but rotated. So the side lengths should be the same. Well, the side across from 60 should be square root of 3 over 2, and the side across from 30 should be 1/2. So now with 60 degrees, my x is 1/2, and my y is square root of 3 over 2. So now I found the 30, found the 60. I just need to find the 45-degree triangle. So we have a 45-degree triangle. And one thing we know about 45-degree triangles, and this is kind of intuitive, but if this angle is 45 degrees and this angle is 45 degrees, the side length should be the same. So whatever this side length is, it should be the same exact value as this side length. And we know the radius is 1. Well, that helps us because now we can use Pythagorean theorem. So we have x squared plus x squared equals 1 squared. X squared plus x squared, we have one box plus another box, we have 2 boxes. And that's just combining like terms. So if you forgot how to do that, or if you thought this was x to the 4th, you'd be wrong. But anyways, 2x squared equals 1. We can solve this. We get x squared equals 1/2. Take the square root. And we get the square root of 1/2. But the square root of 1/2 is the same thing as the square root of 1 over the square root of 2. Square root of 1 is just 1. 1 over square root of 2. But as mathematicians, we don't normally leave radicals in the denominator. So we're going to do something called rationalizing, which is where you multiply that radical on the denominator by itself. You get square root of 2 over 2 over the square root of 4, which is just 2. So both of these side lengths are square root of 2 over 2, which means my x-coordinate is square root of 2 over 2, and my y-coordinate is square root of 2 over 2. And sorry if this looks messy, but it is what it is. Alright, so now we have almost enough information to fill out this unit circle. We should at least be able to fill out the coordinates. So because this point here is from the origin to the center, we know the length of this line here is just 1. The length is 1. So that's how far we went to the right. So that's my x-coordinate. And I didn't go up or down any, so 0 is my y-coordinate. So we can at least fill out these quadrantal angles, is what they're called. And we just did these, and sorry if it's not as neat. Square root of 2 over 2, and this is 1/2, and this is square root of 3 over 2. So if we have the first quadrant, we can just map these points across. So if we take this first quadrant and just flip it over here, the coordinates should be the same. So 1/2 square root of 3 over 2, square root of 2 over 2, square root of 2 over 2, square root of 3 over 2, 1/2. But because this time we're going to the left and then going up, all these x coordinates should be negative. And the negative should actually be inside this parentheses. Just FYI. I just don't have a whole lot of space. Same thing down here, except both x and y are negative. I don't know what that is, so I'm going to erase that. And try one more time. Negative 1/2. This is negative square root of 2 over 2. Negative square root of 2 over 2. Negative 1/2. Negative square root of 3 over 2. And we just flip them over to the fourth quadrant. So these coordinates flip right over here. Except we go to the right and down, so the y would be negative. So we get 1/2, negative square root of 3 over 2, square root of 2 over 2, negative square root of 2 over 2, and square root of 3 over 2, negative 1/2. So we filled out all of our coordinates. And then the degrees, we can do those too. We have 0, 30, 45, 60, 90, 120, 135, 150, 180, 210, 240. Actually, that's not 240. That is 225. And we get 240. 270, 300, 315, 330, and 360. And once you have the degrees, there's actually a formula to turn degrees into radians, which are these last blanks. So whatever degree you're given, let's say 45, you're going to multiply that by pi over 180. And multiply a fraction straight across, 45 pi over 180, and then you simplify 45 over 180, which becomes 1 pi over 4. And you can do that to all these degree measurements and get the radian measurements. And you would fill those in. So I'm going to let you guys do that, but we need to know this unit circle for the next couple things we're going to do. So I want you guys to practice filling out this unit circle, firstly, and then secondly, these coordinates here, the x corresponds to cosine, and the y corresponds to sine. Because remember, we had these triangles. The triangle was always, the adjacent side of that triangle was always this bottom part, and the opposite side was always this y. So the part that goes horizontal over 1, because this is 1, anything over 1 is itself. So x over 1, adjacent over hypotenuse, would be cosine. And then opposite over hypotenuse would be sine. So x corresponds to cosine, y corresponds to sine. So if I want to know sine of 225 degrees, I would just look at this y coordinate and get negative square root of 2 over 2. So it applies for any of the other ones. Last thing, if x is cosine, y is sine, tangent, which is opposite over adjacent, would be y over x. So tangent of theta equals y over x. All right.